Welcome back to another Unreal Tips and Tricks. In this episode, we'll continue to delve into post-process material masking tricks. In a previous tips and tricks, we looked at the custom stencil buffer and how we could mask out different objects, giving them each their own rendering style based on which stencil buffer ID they were using. This time, we'll be looking at how to use the custom depth and scene depth render targets to mask out objects. As before in part 1, we need to go to our project settings and then search for depth. From here we need to go down to engine rendering, post-processing, and make sure that custom depth stencil pass is enabled. If you recall from part 1, we talked about the G buffer on the video card and how Unreal's rendering system uses render targets of the various aspects of our scene render. Those render targets are then sent to the G buffer and put together to create the final render. And remember, if we go to our view mode, we can then go down to buffer visualizations and we can preview all of those different render targets. In this case, we're going to be making use of two render targets, and the first one is going to be the custom depth buffer. Now when you turn this on, everything is going to look black in the scene, and that's because we haven't enabled any objects to make use of the custom depth buffer. But if we go back to our buffer visualizations and then choose scene depth, we can see that the entire scene has a grayscale applied to it. Objects that are closest to the camera will be rendered darkest, while objects further away will get brighter and brighter. In this case, we're going to be using the custom depth buffer applied to this mannequin so that we can mask him out from the rest of the scene. So, in order to do that, we need to select the mannequin, and then on the details panel, we'll search for depth. Here under rendering, we just need to enable the render custom depth pass option here. Now, if we go back to buffer visualizations and then select custom depth, we can see that the rest of the scene is now black while the character is making use of the custom depth buffer. And so he's rendered in a slightly gray tone. We can go back to lit mode now. So the next step is to create our post-process material. For this, we'll select our post-process volume and then we'll search for material to bring us to our post-process materials. If you recall from before, a post-process material is a material that can be applied to the entire screen in what we call screen space. And these materials can apply all sorts of effects. And in this case, we're using them to create masks. To add our material, we need to add it using the Add Elements button on the array of materials here. This gives us a new element, and we'll use the drop-down to choose Asset Reference. From here, we're ready to plug our material in, but of course, we're going to need to create one. We'll call this material ppm and then custom depth. As before, we need to change the domain of our material from surface to post-process, allowing us to use this material in our post-process volume. In our material, we're going to need to get access to the different render targets. In this case, we're going to need 3 of those render targets, and that means we're going to need 3 scene texture nodes. In the first part, we talked about how scene textures give us access to the different render targets in Unreal. The first one we're going to need access to is our raw post-process input. So on the details panel, we're going to select post-process input 0. And this gives us a render of the viewport without any post-process effects applied to it. Now I need to copy and paste this twice. And we're going to need to get access to the custom depth and scene depth render targets. So for the first one here, we'll go ahead and select scene depth, which you'll find right at the top. And then for the second one, we'll need custom depth, which is found around the middle, right above the post-process input. I'm going to reorganize these so my custom depth is on top here. And we're also going to need a color value. We're going to mask the character out using a color, so the character will be rendered as that color. So for that, we're going to use a vector 3, and we'll set the default color in this case to a value of white. If you remember from part 1, we used a lerp to do our masking, so I'm just holding the L key down to create that lerp. And we're going to use the full color of our scene here. We're going to plug that into the A part of our lerp, and then we'll plug our color here into the B input. And we'll be using custom depth and scene depth as our mask. So what we want to do is we want to subtract the scene depth from our custom depth. So we'll pull off of the color of our custom depth and do a subtract. And then we'll pull off of the color on our scene depth and plug that into the second input of our subtract. From here, we want to make sure that we clamp our values between the proper ranges of 1 and 0 for an alpha mask. And then we can plug that into our alpha channel on our lerp. And then we'll take our lerp and plug that into our result node. You can see we have an error here, and it's just letting us know that we're mixing float 3s and float 4s. So we're using RGB alpha as well as just RGB. To fix that, we're going to add some masks here. So I'm going to pull off of the color output of my post process, search for mask, and we're going to specify the red, green, and blue channels on that only, and plug that into our A input. And then we'll do the same thing off of our clamp. We'll pull off of that, search for mask, and in this case, we only need the red channel. And then we can plug that into the alpha channel. One last thing so that we can easily modify this, let's convert our color here to a parameter, and we'll call it masked color. Now we simply need to right-click our material and convert it into a material instance. We'll call this ppmi_custom depth. And now we can plug that into our post-process material array. Now you can see right away that we do have some masking going on, but what we have is the opposite effect of what we expected. So the entire scene has been masked out in white while the character is being fully rendered. And this gives us sort of a matrixy room effect. And if we open up our material instance, we can change the color of the mask. So let's go ahead and make it a red color instead. Now the other thing you're going to probably notice is that the character has a bit of a jittering effect. This jittering effect is caused by temporal anti-aliasing. And there are a couple of ways to deal with this, and the way we'll be doing it is using our material settings. So we'll need to load up our custom depth material again. On the result node, if we scroll down to the post-process rollout, you'll find a blendable location. Currently, the blendable or post-process material is being rendered after tone mapping. This is the default setting. But if we change this to before tone mapping, you can now see that the jittering is gone. Now let's say we want to reverse this so that the character is being masked in red while the rest of the scene is fully rendered. Back in our material, we simply need to add an inversion node. So after the subtract here, we're going to pull off of that and search for 1-. 1- will allow us to flip the blacks and the whites in our mask. And we'll plug that into our clamp. And now we can see the character is fully masked in red while the rest of the scene is full color. Now obviously this isn't the only way that we could mask the character out. We could apply all sorts of other effects to him. We could make him black and white, or we could have the color more translucent, perhaps have it pulse as if to say the character is being selected. We could even have an outline applied this way. There's all sorts of effects you can achieve using masking like this. Alright, so that covers masking using the custom depth and scene depth buffers. So we'll see you then on another Unreal Tips and Tricks.